Good evening, all. Good evening, all. My name is Ganesh Shankar Bhandari, and I am a PMRF PhD research scholar in IIT Roorkee, and I am here to take the live session for NPTEL course Principles of Extractive Metallurgy, taught by Professor Tarun Kumar Kundu. We will start with the previous week lectures revision. Then, based on the previous week lectures revision, we will go for some MCQ based problems that will help you in further solving the assignment problems given in this particular course. Let's start with the previous week lectures. Okay, before that week lecture, in the previous before that previous week lectures, we have learned about the extraction of copper in which is a most important non-ferrous metal in our day-to-day life. So in this week lectures, we will talk about some more non-ferrous metal extractions. Uh, we will talk about the extraction of lead, tin, molybdenum and tungsten. So we will talk about some more non-ferrous metal extraction, how they are extract from their particular ores, what are the processes involved during the processing, during the extractive metallurgy of these particular non-metallic elements, non-ferrous metallic elements. First we will talk about the extraction of lead from their particular ore source. We will talk about resources and beneficiation of lead ores, then thermodynamic of reduction of lead ore, or we can say PBO, and then how the blast furnace reduction smelting is done for the extraction of lead from their particular source, then direct lead smelting process. So generally, the lead, as we had already learned, um, all elements are generally found in some ore from which they can be economically extracted. So the commercial mineral which is majorly used for the extraction of the lead from their particular ore is galena. That is basically a sulfide ore, which is which is having a formula of lead sulfide, and it generally occur together with the zinc sulfide ore. Like for example, if we talk about the lead sulfide ore, then simultaneously we are going to find the zinc sulfide in collaboration with the lead sulfide ore. So first we have to beneficiate that lead sulfide out from that particular source. Then we have to go for the extraction process. And others some other compounds are also there, or we can say some other ores are also there, like serosicide, which is basically lead carbonate, and then angelesite, which is which is generally found in the form of PbSO4, or we can say lead sulfate. So the most important mineral is which is generally used for the extraction of lead is lead is galena, which is basically lead sulfide ore. So galena is frequently associated with zinc, as I had already told. Wherever you are going to find the galena, you will definitely found the zinc sulfide together. So it will be like 50-50 ratio of most of the time it will be like 50-50 ratio of zinc sulfide and galena, along with some impurities like silica, iron, and other elements. So, minor elements which can be concentrated in lead sulfides are silver, gold, bismuth, arsenic, antimony, tantalum, tin, beryllium, indium, titanium, and mercury. So, these are some elements which can also be extracted from these galena ores. Then ores are mined by open pit or underground method and beneficiated by comminution up to 7 to 10 micron for achieving the proper liberation size to concentrate the lead containing galena ore for the further processing operations. Then generally selective flotations and sometimes high media separations are applied to produce separate zinc, lead and copper concentrate, which contain high grade lead concentrate around 71% to 71 plus minus 7%. Generally in the ore form, you will find galena, you will find lead in. not more than 1% amount. Then proven total world reserves of lead are around 70 million tons and the reserve base being 120 million tons and total indicated resources are 1.4 billion tons. So it is like we are uh, in today's, if we talk about the mining processes, so we are trying to mine this 70 million tons ores while we have reserve base of around 120 million tons, but there are plenty of zinc sources which we have not yet discovered, which are uh, expected to be at around 1.4 billion tons. So, lead oxide, coming to the thermodynamics of the lead extraction process. So, lead oxide or can be reduced by either by carbon or carbon monoxide in most economic way. These reactions are representative in both the sintering reduction and the direct smelting reduction process. So lead oxide with the help of calcium or with the help of carbon and carbon monoxide can be converted into the lead metallic state. However, we are finding we generally the lead is in the nature is found in the form of galena, that is Pb sulfide. So first we have to convert that PbS into the PbO, then only we can go with the carbothermic reduction process for the lead recovery. So at 500 degrees Celsius, reduction of PbO with CO is more favorable than reduction with coke. Reduction with CO provides a greater driving force. So as we already know, in when we are going with the carbothermal reduction process with the help of carbon only, okay, so that is going to be a solid state reduction process, while if we are going with the carbon monoxide as a reductant, so that reaction is going to be a gas solid interface. So that can be a faster reaction as compared to the solid reactions, because gas can penetrate into the pores, however solid cannot. So, pyrometallurgical lead extraction generally includes the first we have to go with the oxidation roasting process to convert lead sulfide into respective lead lead oxides. Then, with the help of this lead oxide, we can go for the carbothermal reduction process after sintering and maybe some agglomeration processes. After that, we can go for carbothermal reduction process to extract the lead metallic part from that particular lead sulfide ore. So, for the carbothermic reduction process of the lead oxide, we generally use the blast furnace, just as we are using in the iron ore reduction process. Like similar blast furnace we use for the lead oxide reduction process for the recovery of lead metal. And center roasting of PVS concentrate for the oxidation roasting of the PV sulfide to create the PV oxide. We use this center roasting machine. Center machine feed is lead concentrate, then return center fines, fluxes of limestone. So it is like similar process as we were doing for the iron ore sintering. So Dwight sintering machine is same Dwight sintering machine is used for the production of the sinter, and for the at the same times they are converting that PVS into the PBO. So feed preparation includes the use of mixing tables and conditioning drums. Moisture control is critical. Sinter is designed for self fluxing in subsequent blast furnace smelting. So during the sintering operation, the lead sulfide is going to get converted into the lead oxide so that it can be easily carbothermally reduced in a blast furnace. Then coming to the reduction smelting process in lead blast furnace. So LBF lead blast furnace is like is having similar structure to the iron ore blast furnace. Then LBF is a water jacketed shaft with a refractory hearth or crucible, generally rectangular in section with rounded ends. And weighed batch of sinter and coke are charged into the furnace by charge car or skip via an overhead feed wing or by conveyor system. The gas usually has closed top with a waste gas collection unit. The furnace may have one row of tubers for air injection on each side, as we had already learned in the blast furnace operations also. We have to provide the tubers for the purging of gas for converting the carbon into carbon monoxide so that it can expedite the process of carbothermal reduction. Then at the bottom of the furnace, lead, bullion and slag may be tapped through separate tap holes or siphon for lead at different levels or discharged together continuously from one point into a 4 hour for separation process. So product temperature bullion which we are creating, lead bullion which we are creating can have a temperature of around 1150 degrees Celsius. and this bullion is transferred by ladle for the further refining processes so that we can create 99.99 purity lead from this bullion. It may use oxygen enrichment, oil or gas injection and preheated blast. Then LBF range in capacity up to 650